All right, guys, next entry in your notebook, go on and put, sorry, my handwriting's pretty sloppy, proportional and non-proportional relationship notes, and get your date in there. We're going to use today's date because we're going to have notes for tomorrow, but they're not very long, so no worries. 10 slash, let's say the 8 slash 15. Move it over there. Okay, so let's talk about direct variation. You took a test today, so what is direct variation? Well, it's simple. It's y equals k of x. So right here, let's just plug in y equals kx. Okay? Oops. It went and changed it. Let's fix that. Alright, so that's all you need to know for that. So then let's talk about a proportional relationship. Now, a proportional relationship, you know what that is. It passes through the origin. So if it passes through the origin, then it's also going to be known as a direct variation. So let's go on and write that in. Alright, so a proportional relationship is just a direct variation. Alright, so let's talk about what a non-proportional relationship is. And when we did our notes and we sorted out those equations on the board together in a class, we had direct variation, then we had inverse variation, and then we had a linear equation, which had a different y-intercept than 0, which is what makes a graph proportional. Does this sound familiar? Like an example of y equals 5x plus 2. That's an example of a non-proportional relationship. Whereas one that's a proportional relationship is just going to be written as y equals, for example, use the same 5x. That would just be a proportional relationship, meaning that our y-intercept is at 0. Okay? It's really ugly. Let me fix it. All right, so your y-intercept is at 0, 0. Okay? And on this one right here, on the non-proportional, the y-intercept is at what? Right here, positive 2. Alright, so y-intercept, and that would be 0, 2. Okay, so for definition for a non-proportional, we're going to write any linear function that cannot be expressed by our y equals k of x. Alright, so let's write that in. Alright, so go on and get that written in as your definition. And like I said, anything with y equals k of x is going to be considered a proportional relationship. And anything that's written with y equals mx plus b, meaning b is something other than 0, is going to be a non-proportional relationship. Okay? So it'd be written more like this. Okay? Well, let's scroll down to some of our examples. Alright, so example 1 says, write an equation in function notation for the graph. Function notation is real simple. It's just, instead of using y, we use f of x. Okay, so we use f of x instead of writing y equals. Okay, you would use this instead of this right here. Well, here I am talking like my mom. You would use this setup as opposed to y equals. Okay? Alright, so write an equation and in function notation for the graph. So they've given us a line. Let's look at this line for a moment. They've placed some points on this line. Looking at the line without even paying attention to what ordered pairs we have there, what do you notice about this graph? It's very simple. You notice that it passes through what? It passes through the origin. So because it's passing through the origin, we know right away that this is going to be a proportional graph. This is going to be y equals kx. Okay? This is a direct variation. It's proportional. Hey. Alright, let me go ahead and write proportional. I'm going to put it up here. Wow, that looks really bad. Because it's passing right here through the origin. Alright, so now let's go on and plot these points. Okay, let's start with this in the negative section first. So I have start at your origin, I go over 1, so negative 1 down 2. So I'm going to have negative 1, negative 2. Okay. And then the next one, start at the origin. I don't go anywhere on my x-axis, so that's 0. And then my y-axis, I don't go anywhere either, so that's 0 again. And then right here, we're going to go over 1, so write in 1. And then we're going to go up 1, 2. So 1, 2 is that point. And then let's go to this next point. We're going to go over 1, 1, 2. Remember, don't actually count the line that you start on. And then we're going to go up 1, 2, 3, 4. So let's go on and write that in. Okay. All right. So now let's find our k. Remember how to find k? You take the difference between your y and your x, and you divide y over x. So 4 minus 2 is going to give us 2, and 2 minus 1 gives us 1, which then gives us 2 over 1, which is equal to 2. So our k equals 2. So if I was to write that as an equation, I would write that as y equals 2x, or f of x equals 2x, because remember, it told us to write it in a function notation. So this is the function notation right here. Okay? Remember, it's passing through the origin, which is why it is a direct variation and proportional. This is the main way we're going to be giving our answers, but every now and then they'll ask for it as a function notation, which basically just means write it f of x. That's all that means. All right, let's go to example number 2. All right, so example 2 says, write an equation in function notation for the graph. So we also needed to use our f of x again. So we're going to write it as f of x. We're going to do it both ways, though. Okay, so first things first, let's look at our graph. Does this graph, does this line, just looking at it, pass through the origin? It does not. It doesn't pass through the origin, so because it does not go through the origin, it's going to be non-proportional. Wow, that's really ugly. But you get the gist of it. All right, so let's go on and plot our points. Okay, let's start with our negative one, our negatives. Okay, and if I start here, I'm going to go start the origin, go to the left 1, so negative 1. And I'm going to go down 1, 2, 3, so negative 3. All right, now let's do the next one. Let's look where our next point is. It's on our y-axis. Okay, so notice this one is not proportional, and if you notice, our y-intercept is not at 0. It's actually at 0, negative 1. So we're going to go over here and do 0, negative 1. Okay, couldn't really see that very well. All right, 0, negative 1. And the next point is going to be 1, 1. And the next one is going to be over 2, up 1, 2, 3, 2, 3. Okay, but we still need to go ahead and find our k. Even though it's not going to be, it's not a proportional relationship, we can still find our k. So I'm going to do the same thing like I would do if this was a proportional relationship. And 3 minus 1 is 2. And 2 minus 1 is 1. And remember, k equals y over x. And remember, k also equals m. All right, so when we go to start writing this as y equals mx plus b, you're going to do the exact same thing. So if I do y, which is 2, over 1, my k now equals 2. Okay? But when I go to plug this in to see if it's true, and I plug in right here, okay, 2 times 0 is not going to give me negative 1. So that means I'm going to either need to add or subtract 1. I like to start right here where there's a 0. I like to start with the y-intercept because it makes it easiest for me to figure out if I'm going to need to add or subtract. So on this one, if I'm doing 2 times 0, right, and I need it to equal -1. Well, 2 times 0 is 0. So what I would have to add there to make this true would be to subtract 1. Because if I do 0 minus 1, I'm going to get a -1. So let me retell you that one more time, make sure you understood what I just said. All right, so because I know that 2 times 0 right here equals 0 and not -1, I know that I'm going to need to either add or subtract. Start with your y-intercept wherever your x is 0. That makes it the easiest for you. So then 2 times 0 is 0, minus 1 gives us our -1. Therefore, our equation is going to be y equals 2x and our y-intercept of -1. Okay? And we can subtract 1 from all of them when you go to plug it in. So for example, if I wanted to plug in x for -1, I would do 2 times -1, which would give me -2, and then -2 minus 3, or -2 minus 1 would give me -3. Let me write that in so you see what I'm saying. 2 times -1 minus 1. That gives me -2 minus 1, which equals -3. All right. Same thing works if I was to plug in for x at 1. 2 times 1, right, times a +1, and then minus 1. So 2 times 1 is 2, minus 1 equals 1, which is what we have right here for our y. All right, so whatever you get for your equation, you need to be able to plug it in and solve for the entire table. So our answer is y equals 2x minus 1, and also f of x equals 2x minus 1. So these are the answers that I'm looking for. All right, one more example, and then you're going to need to go to Canvas. At the end of the slide, I went ahead and put your table of contents in that you're going to need to have for your notebook test that you're going to have next week. I'm probably going to do that test on either Wednesday or Thursday. All right, let's go to example number 3. All right, example 3, it says, the total snowfall each year of a winter snowstorm is shown in the table below. Write an equation for the data. So we don't need to do the function anymore, the function notation, just the equation. So this table is a little bit different. It's given to us horizontally rather than vertically. All right, so I'm going to go on and rewrite it real quick over here to the right because I prefer mine to be vertical. So this is my hours, remember? Hours are time. So I'm going to go on and label that X, and the snowfall, if I could get it to right, and then the snowfall is Y. All right, so first hour 1, 2, 3, 4, and then inches 1.65. Wow, that's kind of hard to read. Give me just a second. All right, there we go. Take a second to go on and set up your table vertically. I'm going to have to move mine over a little bit so I have room to write on the edge. Leave room on the edge of your paper over here so you're able to, do the difference between two numbers. Okay? So, honestly, I have no idea if this is proportional because I don't have a graph just yet. So what we need to do is we need to figure out what our K is going to be. Okay? And then go from there. So we need to see if by every hour, if the snowfall is proportional, meaning that if 1 hour it falls, say, 2 inches, then that means the second hour 2 more inches should fall. And then the third hour, another 2 more inches would fall, which would give us a total of 6 inches that have fallen, if it's proportional. So in this case, we're going to have to actually work it out because it's given to us in decimals. So let's go ahead and find the difference between these two and these two. So let's do 6.6 minus 4.95, and that's going to give us 1.65. So right now I'm looking, remember K is y over x, so 1.65, and then 4 minus 3 is 1. Alright, so let's see if that works. So that means if we did this correctly, it means K equals 1.65. So for hour 1 times 1.65 is 1.65. All right, so let's look at hour 2. Let's go on and multiply hour 2 times 1.65. So, 2 times 1.65. Let's see if that's true. That's 3.30. Let's try 3. 3 times 1.65. Maybe I'll put in parentheses. It might be easier for you to read it that way. All right, so let's try that and see what we get for that. If we did this correctly, then it should be 4.95. And that's what I got when I did it. And then check for 4 yourself. And then tomorrow in class, tell me if it was correct. Actually, what am I talking about? Scratch that. We have to write the equation. So I'm going to go on and do it real quick. And 4 times 1.65 equals, let's see. I bet you anything gets 6.6. And it is 6.6, which is what we said. So the snowfall for this day or whatever in winter is a proportional problem. It is proportional. So it is a direct variation. Okay. So if I was to write it, remember we said K equals 1.65. So when I go to write it, I would write it as Y equals 1.65x, meaning for whatever hour has gone by, I'm going to plug in place of x and multiply it times 1.65, and that should tell me how much snow has fallen. If I was going to graph this, okay, if I was going to graph it, all right, if I was going to graph it, because it's proportional, it's going to pass directly through our y-intercept, or directly through our origin, like so. I don't know what happened. I accidentally paused or started it over. I don't know. Anyway, this part right here would not be here. Okay? It would just start at the origin and go up. All right? That's it for the notes. Make sure you go on the Canvas to check for your to do your Canvas quiz. And then on this very next slide is the table of contents. So make sure you check it to see if you have all your notes in that you need. Remember, all the notes are uploaded on my website. I think there's 1 or 2 that are not. I'll make sure to upload them just in case. All right, see you tomorrow, guys.